So MN, which is yellow, corresponds to ST, yellow here. And then LN, that's the pink here, corresponds to RT, which is pink on this side. And that's what I'm showing here. But these are the sides that correspond to each other. And then down below, you're to have written the proportion. That the ratio of the LM, which are the blue sides, that ratio is equivalent to the ratio of the MN, where's MN, the yellow sides. It's rate, and then also equal to the ratio of the NL of the pink sides. Then they want you to find scale factors here. You guys should be pretty good at finding scale factors, right? We need to complete the similarity statement. So we're going to complete the similarity statement and then find the scale factor. So we need to go ahead and to do this, the order is super important, right? L, these are oriented the same, so it's easy to find. L corresponds to R, K corresponds to Q, M corresponds to S. We need to make sure then that in our similarity statement that L and R correspond to each other, that K and Q, and then M and S correspond to each other here, okay? So that's very, very important on the similarity statement. And then the scale factor, remember what the scale factor means? What did I multiply the original by to get to the image? So what did I multiply this 6 by to come up with 4? And I solved it as an algebra problem. I came up with 2/3. 7 is done the same way. 9 is the same idea as well. Okay? I'm not sure you have questions, comments on that? Are you sure? Okay. All right. Well, that's good. Let's see. What else is going on here? Did Tyler ever come in? No. And who else am I missing? That's pretty much it. Okay, not too bad. How's this coming? So let's, it's hard to talk to all of you because all of you in the room. I guess what I want to do now, I'm going to go ahead and I want to take a look at the lesson on similar triangles. So we'll go ahead and take a look at that. And then give you the assignment. We'll go into breakout rooms and work on the assignment together, okay? That's sort of the plan. Let me see if I can get this figured out here. So let me go to Google Classroom. We'll go ahead and take a look at that, okay? So here we go. Let's see. Okay. So I'm going to go ahead and go to assignment 13. This is the one that's due tomorrow. And here we're going to talk about similar triangles, okay? So what's going to happen on this? The assignment is going to be basically looking at the notes. I'll go over the notes in just a second. And then doing these 6 problems down below. That's the assignment, okay? And so when we talk about similar triangles, the same 2 rules are going to apply, that the corresponding angles must be congruent and corresponding sides must be proportional. However, when we're talking about similar triangles, there are shortcuts. There are 3 shortcuts we can use to identify similar triangles. So I want to talk about those shortcuts today and then how can you can use them to identify similar triangles, okay? But again, similar triangles are the same. They're an enlargement or reduction that's proportional so that the shape does not change. And the 2 rules apply. The corresponding angles are congruent and the corresponding sides are proportional. Those must apply. But we're going to show you 3 little shortcuts to help you identify when angles or triangles are similar. And to do that, I'm going to go ahead and show you the short video here. So let me get this going. Here it is. So let me go ahead and show you this. I don't think it's too long, so we'll take a look at it. I think it's 6 minutes. And so check.
This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I'm going to talk about three kinds of triangle similarity: side-side-side similarity, side-angle-side similarity, and angle-angle similarity. Let's start with side-side-side. With side-side-side similarity, we can say that two triangles are similar if the lengths of their corresponding sides are proportional. So let's see what this means. I've got two triangles here, triangle ABC and triangle DEF, and I want to see if they're similar. So here's what I'm going to do. I'm going to take a pair of corresponding sides. Looks like side AB corresponds with side DE, and I'm going to make a ratio of their sides. So side AB is 12 units long, and side DE is 8 units long. So the ratio of their sides is 12/8. Then I'll take another pair of corresponding sides. I'll take side BC and side EF. Side BC is 6 units long, and side EF is 4 units long. So the ratio of their sides is 6/4. And then I'll do the same thing with the third pair of corresponding sides. Side AC is 15 units long, and its corresponding side is DF, which is 10 units long. And now I want to see if these three ratios are equal to each other. I could do that two ways. I could reduce each of these fractions, each of these ratios, and see if they're the same. Or I could take pairs of ratios and cross-multiply. So let's take a look at that, because they look like fairly easy numbers to use. 12 times 4 is 48, and 6 times 8 is also 48. So that means the fraction 12/8 equals the fraction 6/4. Let's see if 6/4 equals 15/10. I'll cross-multiply here. I'll multiply 6 times 10, and that's 60. Then I'll cross-multiply 4 times 15, and that's also 60. So these three ratios are actually the same thing. That means the three sides are proportional. So we can say that these two triangles, ABC and DEF, are similar. I'll write that as triangle ABC is similar to triangle DEF, because we've shown that the ratios of their corresponding sides are all the same. So the sides are proportional. Let's look at side-angle-side. With side-angle-side similarity, we say the two triangles are similar if they have two pairs of corresponding sides that are proportional, and if the included angles are congruent. So here I have two triangles. I have triangle ADE, and then kind of inside triangle ADE, I have triangle ABC. Now both of these triangles share an angle. They share angle A. So I know that angle A is congruent with angle A. Now I have to see if the sides on both sides of angle A are proportional. So I'll take side AB. The length of AB is 9. And I'll start making a ratio. The corresponding side would be AD, and the length of AD is 9 plus 3 more. So the ratio of AB to AD would be 9/12. And now I'll take the other pair of corresponding sides. That would be AC and AE. The ratio of their sides is going to be 12, that's AC, and 12 plus 4 more for the length of AE. So I've got a ratio here, 9/12, and I want to see if that's equal to 12/16. I'll do this by reducing both fractions, both ratios. I can take 9/12 and divide both the numerator and the denominator by 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. And then with 12/16, I can divide the numerator and the denominator by 4. So 12 divided by 4 is 3, and 16 divided by 4 is 4. And for both of those ratios, I've got them reduced to 3/4. That means that triangle ABC is similar to triangle ADE because they had two pairs of corresponding sides that were proportional, and the included angle, this angle A here, is congruent. Angle A is congruent with angle A. Okay, let's do angle-angle similarity. With angle-angle similarity, we say that two triangles are similar if they have two pairs of corresponding angles that are congruent. So here I've got two lines, BD and CE, and these lines intersect at point A. So at point A, we have vertical angles. So I know the two angles that are formed here are going to be congruent. Angle BAE is congruent with angle DAE. And then we've also taken these two line segments and formed them into triangles by adding side BC and DE. Now, looking at the two triangles, I see they also have corresponding right angles, angle ABC and angle ADE. So I've got two pairs of corresponding angles that are congruent. The two vertical angles are congruent, and the two right angles are congruent. So these two triangles must be congruent. The two triangles must be similar. Triangle ABC is going to be similar to triangle ADE. Okay? That's it. Take care. I'll see you next time.
All right, so just wanted to kind of show you that. So basically what all that he went through was trying to show you that you can show that triangles are similar, not only by showing that all three of the angles are congruent, that the corresponding angles are congruent, or also showing that the corresponding sides are proportional, but you can take these shortcuts. You can show through SSS, side, where you show that the sides are proportional to each other. You can show through SAS, we have two sides, two pairs of corresponding sides that included angle. The sides are proportional, the angle that's included is congruent. That's SAS. And then AA, just showing that two angles from one triangle are congruent to two angles from another triangle. That means that the two triangles are congruent. So that's kind of like what I want you to look at today. We'll be looking at those shortcuts. I'm going to go ahead and take a look at the Google Classroom. So we can look at the assignment now. Where is it? It's right here. Let me get back. So here's the assignment here. It's this page. On it, these definitions and these examples are essentially what was explained in the video. And then you need to do the 6 problems on the bottom. So I'm going to go ahead and go through this with you right now. I know it's long. Sorry about that. It's a long session today. But anyway, we'll go through that and then break out into breakout rooms, whatever, and kind of work on these problems, see how it goes. Okay, first questions, comments before I go any further. Okay, let me go ahead and turn on my document camera. Okay, so let's take this off. And let me take this out of the way. All right, so there are 3 ways to show that two triangles are similar. I mean, obviously they have to fulfill their requirements, right? That the corresponding angles are congruent and the corresponding sides proportional. But in addition, instead of that, we can go with these shortcuts. And here it is. If we can just show that two angles of one triangle are congruent to two angles of another triangle, we can then safely conclude that the triangles are in fact similar. Okay, so let me show you an example of that. They're not in the examples, by the way. It's the problem number 1. So let me show you problem number 1 right here. So let's see. I've got, let me call in some people here. So Carlos. So we've got triangle ABC and triangle DEF. They're oriented the same. What can you tell me about angle A and angle D? What do those arc marks tell me about angle A and angle D, Carlos? Hello, Carlos.
What?
There you are. Hi, there you are, Carlos. I'm asking you a question. So I'm looking at number 1, and I'm kind of trying to do an example of what they're calling a similarity, another angle similarity, showing that two angles of one triangle are congruent to two angles of another triangle. So I'm just trying to illustrate that here with this example, and I've chosen to do number 1 as kind of where that sort of pops up. All right, so the question is, see angle A and angle D, and see these little arc mark there? What does that tell me about angle A and angle D, Carlos?
Are the same?
Exactly, they're the same measure. That's exactly right. Very good. Thank you. Derek, how about you? Look at angle B and angle E. See the two arc marks here? B has 2 marks and E also has 2 marks. What does that tell me about the measures of angle B and angle E, Derek? Derek, are you there? Hello. Sophia, what can you tell me about angles B and E? See how they have the same 2 marks on them? What can you tell me about those 2 angles? All right, Ayana. Hello, Ayana. So we're looking at triangle ABC and triangle DEF. I'm looking specifically at angle B and angle E. See these 2 arc marks there? What does that indicate about angle B and angle E, please? Alrighty, mark that. Let's see, Jair. So I'm looking at triangle ABC and angle DEF. What can you tell me about angle B and E? Jair, hello. Okay, Ashley, now that you have a really nutritious breakfast, what can you tell me about angle B and E? There's 2 marks here and 2 marks here. What does that tell me about angle B and angle E? Folks, you need to answer. Even if you're not sure, you should say, I don't know, I don't remember, or I'm not sure, or could you ask the next person or pass? But just respond so I know that, that you're actually there and paying attention. Can you do that, please? Hector, so I'm looking at triangle ABC and triangle DEF. What can you tell me about angle B and E according to the marks here? This has 2 marks on it, and this has 2 marks on it. What does that mean about those 2 angles?
I heard about it, but I keep forgetting sometimes.
How would you say it in different words? You don't have to use a mathematical term. What would you say just using your own words? They're what?
I was going to say right angle, but that's not the right answer.
No. Okay, so let's get down. Let's see, Catherine. What does it mean when I have 2 marks on B and 2 marks on E? What does that tell me about the 2 angles?
They're the same measure.
They're the same, right? So, Hector, so see A and D, see how they have that one little mark there and 1 mark there? Hector, you know what that indicates? That they're the same measure. Do I know what their measure is? No. We don't know what it is. All we know is they're the same. Okay, so Hector, how many marks do you see on B and E?
2.
Exactly. So B's got 2 and E's, you know what that tells you? They're the exact same measure, right? Okay, so then knowing that, I can see that I've got a pair of corresponding angles here that have the same measure and another pair here. So I've got 2 angles from triangle ABC are congruent to 2 angles from DEF. Because A is congruent to D. Why do I know that? Because it tells me they are. B is congruent to E. Guess what? Angle. I've just shown that 2 angles from one triangle are congruent to 2 angles from the other triangle. Now, I need to write the similarity statement. Remember, careful, order is important. Triangle ABC, squiggle, that means similar to triangle. And then I need to go ahead and write out the correct similarity statement. So remember, A corresponds to D. So D has to go here because A and D correspond to each other. E corresponds to B. So here's B, so that means E has to go here. And then C corresponds to F. So F has to go here. I can't write that triangle ABC is similar to triangle FDE because A does not correspond to F. A corresponds to D. B does not correspond to D, corresponds to E. And C does not correspond to E, C corresponds to F. So the order is super important, folks. So that's an example of AA similarity. If you just show, you don't have to show all three angles are congruent and all of the corresponding sides are proportional. You just have to show those two things. Boom, and you're in. That's all this is saying up here on AA angle. Now, on side, we're saying that if we can show the measures of the corresponding side lengths of the two triangles are proportional, in other words, showing that the corresponding sides are proportional only, just that only, without showing that the angles are congruent, then we can conclude that the two triangles are in fact similar, and that is here. On number one, that's example number one. So let's see if I can do that with everything in there. Great. So I went ahead, notice they're oriented the same. So I went ahead and I highlighted the corresponding sides. So this blue side corresponds to this side. The pink corresponds to pink, yellow to yellow. And so the ratios are that the length of AC and corresponds to the length of DF. That's what this means. The length of BC, the pink side, corresponds to this length here. So I write that ratio. And then I write a ratio for AB and DE here. I put in the actual numbers, and when I do that, the length of AC is 6 and the length of DF is 9. So there's one ratio, and I simplify it, comes out to be 2/3. Then let's look at another ratio, the ratio of the next corresponding sides, BC and EF. So that's 8 to 12. Simplify, divide by 4. Hey, same ratio, they're equivalent. Cool. All right, and then I'm going to go ahead and check AB, which is the yellow sides, which shows that's the ratio of this side to that, 10 to 15, also 2/3. Hey, they're equivalent. They're equivalent ratios. So what that means is that they are proportional because they're equivalent ratios, right? So that tells me then by SSS that the corresponding sides are in fact proportional. I can conclude then, because of SSS, that these triangles are in fact similar. And then I need to write the similarity statement. A corresponds with D, right? A corresponds with D. B corresponds with E, so B corresponds with E, and C2, 3 corresponds with F, right there. And it sort of makes sense because like AB, which is the yellow, corresponds with DE, right? BC corresponds with EF, BCEF, that's the pink. AC, the blue, corresponds with DF, this blue. So I can conclude then that these two triangles are in fact similar simply by showing that their sides, corresponding sides, are proportional. Now the last one, and I can be quiet. SAS. This says that the measure of two side lengths of one triangle are proportional to the measures of two corresponding side lengths. That's too many words. Okay, so what that's saying is that if I can show that these pairs of corresponding sides, like this is the blue, that the ratio of those two corresponding sides is equal to the ratio of these two corresponding sides, and that their included angle is exactly the same measure, is congruent, then I can conclude that the two triangles are in fact similar by SAS, side angle side. So the first thing I need to do, I'm going to go ahead and set up the ratios of the corresponding sides. So what I did, I went ahead and I highlighted the corresponding sides because they're easy to see because the triangles are oriented the same. So 3 and 4 correspond to each other. So I wrote 3 and 4. And then 6 and 8 correspond to each other. So I need to see if those ratios are in fact proportional. And I can do that just by checking cross products. 4 times 6 is 24. 3 times 8 is 24. Boom, they are. So those corresponding sides do in fact form a proportion. Number one, that's SS. And I got to see, does this work, is the angle that's included between them, is that angle congruent? It's the same measure, and it definitely is, right? Angle N is congruent to angle R. And that's what it's saying. The measure of angle N is equal to the measure of angle R. So that means that the two angles are congruent. So I can conclude then by SAS that these two triangles are in fact similar. All right, I've been talking way too much, but what I wanted to show you have three examples of AA. The example for AA is here, the first one. You have an example of how to determine SSS, and then you have an example of SAS here. You need to do 2, 3, 4, 5, 6 figure to finish this up. We'll actually do 1 through 6, please, okay? So do that. I want you to kind of play with that and give that a try and then see how that goes. Do you have any specific questions or comments for me on this or anything else? All right, I'm going to dismiss you. I've been sitting here, I've been torturing you terribly long today, and I apologize for that. But thank you for coming on. And we'll see cohort A tomorrow morning at 8:30. Cohort B, we'll see you tomorrow.